Hello everyone. Thank you for this opportunity. Thanks to the coordinators and the event organizers. Thank you for inviting me here. The topic that I am, as she said, like beyond the hype, AI across enterprise and open sources. So before I begin, I would like to invite CEO and founder of Caze Labs, which is the company that I'm working in. So we are an AI-based company, and I would like to invite Sanil sir. He is also the advisor of this event. So yeah, I would like to invite Sanil sir to the stage. Well, he claims that AI is just a hype. So yeah, let's hear that hype from him.
He put me in a spot. And I have not bribed him to call me. Okay. So today our topic is beyond hype, AI to success, open source, enterprise, and so on and so forth. And he said, I think AI is just a hype. How many of you think AI is a hype? 1, 2, 3, 4, 5. I don't have enough company. Not 50-50. Please see behind. No 50-50. It's even 5%. I don't have company. Exactly. You come to DevCon, AI DevCon, and ask that how many of you think it is hype. But there is a chance, right? People come here to see whether it is a hype or not. That is also a possibility because we evaluate everything, right? That's our human tendency. Okay, let's see whether it is a hype or not, right? So in this session, we have 2 stories they will explain. One story is for you to do a homework, okay? So we would like to share you that some of the things what we have done and with the open source and how it went, okay, with AI. Usually, the last talk I had, 100% I generated by AI. This, I thought only 3-4 slides I will make myself. I think I made a mistake. Okay, 3 stories in 3 different domains. One is research and social impact. Second is open source incubation. And third is enterprise optimization. The first one, if you see, we have built a tool called MedPro AI. It looks like medicine because it helps doctors. So it's a doctor assistant application. Why did we do it? Because some doctors told their pain. We'll see what the pain was. Now, if AI was not there, probably we would have not been able to build this solution this effective and faster. The problem statement is simple because they had a lot of documents, standard documents and guidelines for treatment, the standard treatment procedure. And you know doctors, they only treat, right, in hospitals? How many of you think that doctors only treat? Okay, like my previous speaker told, you are our energy. You need to give energy for us. First of all, we are tensed. Really? So you need to give the energy for us. Okay, how many of you think that in hospital, the senior doctors only do treatment? Okay, I'll change the question. How many of you think that they don't do treatment? Now also nobody will raise. Yeah, this is interesting stuff, right? Okay, so for the treatment, because in hospitals, they do a lot of other activities. You can talk to a senior doctor in a hospital. Not only treatment, maybe 20-30%. Now, they are busy with a lot of things. Now, if all these treatment procedures dynamically getting updated because of the research, etc., they don't have enough time to read. And they don't even know that it is getting updated. That is where the MedPro will come and help you. It's an assistant. It is not a doctor. It is an assistant to the doctor. Doctor takes the decision. Like the previous talk, speaker told that human in the loop. I mean, that is where it takes you through. So that's the first one. And we'll see what is the success about it because we have not launched this product. It is in MVP state. Using AI technology, we do also AI native development. So 2 ways it helps. The AI technology to infer from the document. The second is the development itself we have done AI native. Okay, we do vibe coding. Now the next one is an open source project. You know, we give document to ChatGPT, ask questions, it answers. You give 2 documents, earlier 1 document it used to answer, 2 no. But now 2, 3 and all you can give. But 100 petabyte of data, whether you will get the correct answer or not, doubtful. Now that is where at scale you want to infer from data. That's not easy. Now AI comes into play. AI, LLM, MCP, all these things will come. This technology will help you to infer faster. Now, AI is like anybody else. It's an analyst or it can be an architect. But now you need to talk to him better. You need to convey to him the correct information. Then only you will get it. The intent should be correct, right? That is where the term called context will come into play, right? You need to set the context to him. So we built a product, solution, open source project, how to give this context better based on different data. So it's a completely open source project. And we will see what is the success around it, right, in the next slide. Third one is some of the products, because we are a startup and it's a bootstrap company. Unless some of the requirements are compelling, at least you think that it is compelling, you will not do it, right? Selling is a second aspect of it. At least you will not do it. You will not invest your time, right? Now you see that there is a pain point in the industry. Now we thought that it is valuable. Now the solution, if AI was not there, we would have not been able to provide this kind of solution today. So it helps in hiring, it helps in cost saving. Because it is not a marketing place, so I am not talking about the product more. Okay. What I am telling is that we could build a product. Okay. Next. Now the first one, the MedPro AI. Okay. It is in MVP stage. And the key point for our success and confidence is that this is already featured in a Linux Foundation research paper recently published, saying that it helps in the social impact section. Okay. So this is a very big confidence for us. And which technology helped us to build this? AI. Okay, next. Soda Contexture is an open source project. So we discussed about this open source project, and now it is incubated in the Soda Foundation, which is under Linux Foundation. It's an open source project under Linux Foundation today, and it is in the beginning, and many of you can join and contribute because it is a context building engine. Okay. And third one, these 2 products. I don't talk about the product, but the point is that we could build these products, and right now we are doing successful production trials with customers. That's the stage of that product. In the sense, these 2 products are really used in their production scenarios today. What is the underlying technology? It's completely AI. Agents, MCP, what you call today, whatever latest technology you talk about, we have tried to incorporate to solve that problems. Okay, so that's a kind of experience what we have. We have multiple products and solutions where AI could help us to get to a production level quality which can be deployed. Okay, so now it's not just a hype, but many of the companies, what we see is that everybody is doing with AI, code generation, and then they think that again 3 or 4 months for the same product life cycle, because we also code and we also want to review the code. After generating 10,000 lines of code, human wants to review it. So these are some catches when you apply AI for your native development. So what you need to do? AI is not for anything. This is a key point. You cannot take AI for anything and everything. For example, a simple search. Regex, why do you need an AI? So you need to know where to use, how to use. So the key point is that best of AI if you want to get. Again, you need to know the use cases, etc., etc. But the key point is that what is your application? What is your data under that application? And which domain? Is it medical? Is it logistics, etc.? Right? So if you align more towards this, AI is not just the hype. Right? So AI can help, and accelerate our development towards the real products in the market. So with that note, we will see two stories about the MedPro. What is MedPro? Why MedPro? By Joval, and Rohith will talk about, take us through the Contexture project. And we also invite you to join the open source project. And CoSense and Higher Sense, we always end with sense our products because we want to make some sense out of it. So those two products, please visit our website. I don't want to market our products today. Thank you so much. I'll hand over to Joel.
Thank you, Sunil. I'll be, as he said, I'll be talking about Caze MedPro AI. This is a product that we made to help doctors with their tight schedules and staying up to date with their informations. And yeah, so these were the points that the doctor told to Sunil sir. So first one is a dynamic stance. The standards, the research, it keeps on growing. So like there are so many changes that's happening. And a doctor's time is very tight. Like he has to give the quality treatment to the patient, but he doesn't have that much time to. So that is there. And there is data privacy issues and complex decisions is what makes the doctor a doctor, because he takes the decisions that is needed for that patient. So he has experience and he has knowledge about how this treatment should be, how this procedure should be done. So yeah, out of all of this, these things to stay up to date, to the standards and procedures and research, it's very difficult for a doctor. So to help with that is why we came up with Caze MedPro. So I'll show you a demo video of how Caze MedPro works. Okay, so this is our landing page. Okay, so yeah. Now over here I'm uploading a PDF of medical research and papers and documents. So we can put like any format in PDF for docx, and our LLM will take that as context to answer. So we are giving a patient information. Her name is Miss Kavita Rao. These are all dummy data, not actual. So we gave a condition, and based on her symptoms is what our LLM gave the answer for. And below you can see that, 1 second. Okay, over here we can see that our LLM has gone through our document and has given the suggested treatment plan and and below we have given the recommendation aligned with American Society of Hematology 2020 guidelines, and this is from where the treatment plan is taken from. So this is based on like documents. When we give documents, then we can also give like web links. So we have given here a web link related to pulmonary embolism. So from there, we're showing how we web scrape and get the information. So clinic overview on pulmonary embolism. So it's taking the information from the web page and it is giving. Yeah. So how this Caze MedPro works is like it has 4 agents. So one agent is only for medical, and the other one is for only patients, and the other one is for patient with medical documents, and then medical to patient documents. So what this means is like, so if you're asking about medical kind of a question. So like over here, what is pulmonary embolism? So it will take only from that document and it will give you an answer. And if you're asking about a patient only, so it will go through all the patient records, find that patient, and gives you the information about that patient. Now, if you're asking like, what should be the treatment plan for Anjali Sharma? So now over here is like your patient information you have. You have to connect it with the medical records and then find the related informations and then create a treatment plan for the patient. So that is what our third agent does, the patient to medical. And then medical to patient is like based on the medical standards, like which patients it's not getting the standard medical practice like treatment, or like if they're lacking anything, or if some medicine is not given to that patient or anything. So to answer such kind of answers, we have like 4 agents. Okay. Now, how did AI help us? How did AI accelerate this? So from 2024 to 2026. So when we started, it was around like 2024 beginning. So we were going through this how to extract all the informations like text, tables, images, hyperlinks. So the context is what the LLM says to the user, right? So if we don't get all the information, then we are missing out on some things. So this enterprise PDF reading, the OCRs have improved a lot, and the tables and images are not just gibberish. It gives you actual answers, which is there in the documents, or it's there in the links. And now we have semantic search and retrieval. So semantic search is like the meaning of what the word says. It's not just the word, or how our LLM works. It's like assuming the next word. It doesn't work like that. So semantic search is like it knows the meaning of the word and takes the information based on that meaning. And then our recent LLM models are trained in the way that it has medical reasoning. So it is trained to go through medical records, or it knows what to connect with, or what to take the information from and give a proper response to the user from this LLM. Okay, so as I said, how our the informations. So the system that we are using over here is called a RAG system, and in RAG it is like retrieval augmented generation. So it's all about retrieving the information, most of the information. So compared to what we had in 2023, the 2026 it has been a really big change to retrieving this information. So table accuracy has gone up from 62% to 94%, and then image understanding was like 10%. Like it was basic OCR. It used to give us very minimal information. It now, because of VLM, we can understand the image, and it has gone up to 92%. So based on this, our overall quality of retrieving the information for the LLM as a context to say to us, to tell the user the proper information, has gone up to around like 18%. So what does these numbers mean? So now 94% of table accuracy means that now our VLLM understands what these tables says, what these tables do. Like it connects the rows, it connects the columns, and gives us the actual information. Now, when I say about 92% of image reasoning, images are being collected, but how is it understanding? It understands by embedding this into like a space where it understands each other, the colors, the patterns, the text, and the images. When it comes together is how the LLM understands, okay, this is what this means, and this is what I should give to the user as a report. So now what happens is so I said there is an 80% of hike. So this LLMs understand. So there is self-reflective loops within this LLM to understand It goes on and on inside itself to give the best answer out of it. Now, if I ask a question and it went through a flow, okay, now it gives back it gives back an answer, right? So if I ask something related to that question, it goes through the same flow, but in a faster way, because it already has that in store, because we have already asked about it. So it also gives us a faster time to receive a response from the LLMs. Now, these are the newest trends in RAG systems. So there is agentic RAG, there is graph RAG, multimodal RAG, knowledge runtimes, context engineering. So agentic RAGs are like we have multiple agents to plan, retrieve, reflect, and self-correct itself. So there is a agentic RAG. Now there is graph RAG where you have multiple, like if you have databases, it can understand from connecting this table to that table. It can give you a graph of how your tables is, and the LLM understands how that context should be retrieved and gives you the answers. So that is graph. And the multimodal RAG is like tables, images, hyperlinks, text. So it understands what all these does and how to extract the information from this and give you a response. And context engineering is how you, when we are talking about RAG, right? See, now we have a lot of informations now. We have text, we have images, we have tables, but our LLM should understand what this is, right? So our context size is going to be big. So now our LLMs are understanding how the context are. So it will know behind it, like which all context should I take, which are the most recent one, which are the most information that I can connect to, so that I can get the correct information from, so that I can give it to the users. Yeah, so that is from my side. So that is about Metro AI. I would invite Rohith to talk about context share. Thank you.
Hi everyone, good afternoon. I'm Rohith and I'm a member of the SODA Foundation. I also work in IUDX in the Indian Institute of Science. So today here, we are here to talk about SODA Contexture, which is a context building engine for LLMs, right? Why do we need context engines, right? Context is something we just give to the LLM so that it can analyze the context and give us some result in return. Turns out that so we primarily want to deal in the problem of monitoring, and any of us who have dealt with cloud native apps can realize how messy this problem is, right? We have, so in the monitoring context, what happens is that if we try to use chatbots to perform monitoring, which people are trying to do, several DBs like Victoria Metrics and so on, they are trying to bring chatbots into this space, but the problem is that the AI is it hallucinates a lot, right? Because the data that we are dealing in monitoring is very, very messy. And we also deal with problems such as consistency, the scale and reliability and so on, which are structural problems to monitoring. We want this to be, we don't want hallucination in these aspects. So we want to address this using a context building engine. So in monitoring, to build a context engine, right? So what are the essential primitives that we must understand about? One is the entities, right? What are we dealing with here? The pods, the containers, the services, the different nodes, the full stack, the entire stack that we want to monitor. The relationship between these entities. How are these related to each other, right? Which service performs a call to which service? And because essentially when we do monitoring, when something goes down, we want to understand the entire trace, right? The semantics of these failures, right? What is exactly happening? Is it governed by certain policy, right? If there is a failure, if I want a business user to get some insight out of what my monitoring agent wants to tell me, is it violating certain policy, right? Is it exceeding certain limits that my policy is not allowing? Also other aspects of security and privacy as to if we read certain logs, what can be revealed and what can't be revealed in these outputs. These are very I would say critical in the enterprise context. If we want to give certain applications, we work with the government and so on, we are governed by strict regulations and what can be revealed and what cannot be revealed. Because essentially we are feeding the entire data into LLMs and the output of these LLMs matter. Right? So this is a architecture diagram of SODA contexture where we have the AI agent interfacing with some MCP services, right? To people who don't know what is an MCP, it's called a Model Context Protocol, where essentially there is a tool call that governs how I query my data from different stores. And the AI agent can, based on the natural language input that I give, the AI agent can essentially pick a tool call and perform the call and then probably analyze the output of these calls, right? So here, as you can see, we have the various operational systems like Prometheus, S3, our data stores, our monitoring systems, and so on. And this is our data sources, right? And this is what we want to query. And kind of the OCS service will sit as a sidecar. Basically, from these adapters, try to make sense of these adapters, capture some essential properties from these data sources, and then feed them back to our LLM so that the LLM has an idea about what it's commenting on and what insights it's generating. Okay. So I'll show you a small demo of our SODA contexture service, which would help you appreciate the problem that I have highlighted. Okay, so now what the user is trying to do, say primarily some SRE or someone, he's trying to query something, say list pods with maximum CPU usage, right? And this is essentially connected to some Prometheus backend. Okay, so you can pause here. So this is the output that the LLM gives us. So it gives us, say, the cluster name here is, say, Prometheus 1. And then we have, it has listed some pods with maximum CPU usage, say the cache, the pod, the API pod, the worker pods, and so on. And here the thing is that it's also giving us the top pods with the highest CPU usage and also checking based on the OCS backend input that we have given that it identifies that there is an SLA violation because we have probably set this violation to be a 90% threshold. And since one of the pods is exceeding this threshold, so then the agent is clearly able to highlight, in addition to retrieving the pod usage that we query from Prometheus, also able to analyze and give us an insight about the SLA that we have set. And one more thing, another thing that in the last line you can see that the cache, right, the workload cache. Since we have identified that the cache is undergoing an SLA violation, we also need one more insight here. That is the relationships that this cache has with our application. So here it identifies that there is the cache and it's being connected probably by the front end and the DB service, right? So also it gives, so LLM is able to identify this, apply the SLA policy, whatever we have fed it here, and also gives us one extra insight that, okay, we might also want to look into these services as well because this is dependent on this, right? So how it's doing this, the backend part of this is that we use the service mesh to retrieve these dependencies. This is how Grafana also does, so that they can get the trace of the various services and so on, right? There can also be a global query such that someone just says, okay, describe the health of this cluster, right? I just want to know the health, how many pods are up, how many pods are down, and so on. So here, the thing is that we have, this is just an example, we have just 15 pods. And so this is the output that is given. It's able to retrieve these 15 pods, check the health of these pods, right? And then comment on it and so on, right? It's also able to clearly identify certain things. That is, okay, so for these pods, we are not going to analyze the CPU usage of these containers, so it's not very relevant here. So we don't have any SLA aspects to this. We have not added that here. So another thing is, we just again queried, another query that we want to show here is, okay, we have given, okay, I don't want top pods in a global level, give me just top 2 pods, right? And it's able to identify these top 2 pods, and again, it's able to comment on the criticality of these pods based on our set SLA. So this is what I wanted to talk about, that we need LLMs in monitoring, and we are starting to use chatbots in monitoring, but the structural problem of monitoring needs to be addressed. So we are interested in not just one service or one pod. We are kind of interested in a global context and in enterprise level constraints that we have. So these constraints have to be encoded into the context of this LLM and built in a way so that the LLM can understand, keep this into account, and then give us an answer. Now, this kind of an answer is very useful to us. Helps a SRE or a business user identify what is actually going on with this application and take remedial steps. Right? Yeah. Okay. So Soda is an active community right now. They have been working in the multi-cloud space for a long time. And Contexture is one of these products. Since we are now AI is coming in and LLMs are being used in cloud native apps more and more. This is the first product on AI, which is called Contexture. And we are an active community. We have presented Soda Contexture. It was featured in OSS Japan in 2025. Yeah. So with this, I also invite all of you guys, professionals, students, researchers, and so on, to join. This is fully open source, so you can join us, talk more about the problem, give your insights on the architecture, and also, if possible, contribute in this thing. So, yeah. Okay, thank you, everyone.